So hey guys, hello everyone. Today I come with another 10 question series video. As you know that I already uploaded molecular spectroscopy and quantum chemistry questions of CSIR-NET, and you can watch the video by clicking the I button. Put the two videos there, and I will continue making this video series of 10 questions. It's very difficult to choose 10 questions of any chapter, but I tried my hard to take questions of different concepts so you can memorize the all concepts and formulas. So this is the coordination chemistry chapter. So today also we'll discuss 10 questions. So without wasting any time, I'll discuss the start discussing the question number one. That is, you can see here that LMCT. It is questions about the correct order of the LMCT, and initially I want to tell means sorry about that handwriting of this, because I am just start making video with this pen tab, so the handwriting will little bit bad, but I will adjust. I'll try to make it clearer to you. So yeah, stay with me till the end. So this is the question about LMCT and the energy order of given of these following options. So we have to tell the which will be the highest LMCT. Before that, we have to know that what is the conditions of LMCT. LMCT, we know that ligand to metal charge transfer. Okay, so the what will be the condition of ligand to metal charge transfer? So ligand transferring charge to metal, as you can see, when a metal will accept charge, means charge means what? Electrons. So then it should be in high oxidation state. Okay, so LMCT is will occur when the metal will be in high oxidation state, and the ligand should be non-bonding. Ligand should be non-bonding because you have to donate electrons. But here you can see that if we see that here Mn7 plus, and here if we calculate the oxidation states, that is for chromium it's X minus 8 equal to minus 2 equal to plus 6, and for vanadium X minus 8 equal to minus 3, that is X equal to plus 5. So higher oxidation is Mn7 plus, it is Cr6 plus and vanadium 5 plus. But if they means the question is about LMCT energy. As you can see, this is the question is different, means if the LMCT order, means which LMCT will be more favorable, that will, the order will be the first one. But here LMCT energies are means order we should give. So it actually depends on the size of the metal and as well as the oxidation of the metal. So as you can see, the Mn7 plus and chromium 6 plus and vanadium 5 plus, if we compare the energies, Mn7 plus will be more electronegative, means more electron deficient, it wants electron, so it will behave as an electron negative, so its energy will be lower. So when the energy difference between the ligand and the metal will be more for vanadium, as it has more size as well. If we can calculate this according to size as well, means as the size increases, the LMCT energies also increases. Okay, so here we know that vanadium vanadium 5 plus has more site than chromium 6 plus and so the answer will be also same. This is will be the answer. But if they ask only the LMCT order, means ligand to charge transfer order, so that will be favorable for this one. But for energies, it will favor the opposite. Okay, so actually it depends on the oxidation state and the ligand electron donating means non-bonding should be there. The conditions are this. Okay, so coming to the next question. If you have any doubt, you can ask in the comment section. I will answer definitely. So coming to the next question, that is the complex of H2O6 2 plus has a very light pink color. Best reason for the for it is, means you can see here that Mn, first you have to see the complex and the metal oxidation state, that is Mn2 plus. It has D5 electronic configuration of D. Okay, it is T2G and it is Eg. So here they are asking that it has a very light pink color, and the best reason for it is, you can read the options as well. The complex does not have a charge transfer and transition, and DD transitions here are orbital forbidden but spin forbidden. DD transitions are orbital forbidden and but spin forbidden. DD transitions are orbital allowed but spin forbidden. DD transitions are both orbital forbidden and spin forbidden. Okay, so what will be the answer? Comment in the comment below. So I think pause the video and comment below before I before before me before discussing the answer. That is, you can see here, if we promote one electron to here, means it will be different in spin. So the delta is not equal to 0. So it is spin forbidden, and here the exchangeable T2G orbitals are not exchangeable. Okay, so it is orbital forbidden as well. Which orbitals are orbital, means which configuration has orbital contribution, that is like D7. You can see here we can easily exchange the electrons here, and the spin change also same. Okay, so the answer will be that D5 system is both spin forbidden and spin forbidden and orbital forbidden. Okay, coming to the next question. So I think you read this question already, that the electronic spectrum of CR F6 3 minus, that is chromium in +3 oxidation state. Okay, so we know that chromium is 3D5 4S1, so it is 3D3. and the electronic configuration is D3. So before solving this question, they are asking that it is showing three bands in the energy with the energy here. Three energies are given, and which of the value is delta 0. So before solving, I can tell the answer just in a single sentence, but I will discuss a little bit more things here. Just to remember, to remind you the orgal diagram. I think with this diagram we can remember everything. Just focus. If we divide, I put this line because in this single picture I will discuss the four type of configuration here, which has three transitions. See, in D1 to D10 systems, there are only two types of transitions. Means metals has one transition or three transitions. Okay, so D2 and D7, and here D3 and D8. This 4 has three transitions, and other means D1, okay, D4, D6 and D9 has one transitions. So how to represent this? Just follow me. Sorry. So just draw this picture in your notebook. It is a short note type thing. This is a T1G. This is T2G. Means these terms are coming from F. Okay, from F it is coming. So this is T1G. This is T2G. This is T1GP, and this is A2G. Okay, so here also it will be T2G, means you can match the cross diagonal thing. This is T2G, this is T1G, and this is T1GP. Okay, so these transitions will be occur. So this is the ground state of the D2 and D7 system, and this is the ground state of the D3 and D8 system. So transitions will be like this. Means let me take another color so it will be more visible to you. You can take a small note here. These transitions. Okay, here also, these transitions will. Okay, so this is new 1, new 2 and new 3. There is a small thing that you have to remember. Another small thing, that is for the D2 system, the 10 DQ, that is delta O, will be the new 3 minus new 1 transitions. And for D3 system and D8 system, that is here, the 10dq, that is delta O, will be nu 1, means the smallest transition. And for d7, that is 10dq, you have to remember these things, otherwise means few things you have to remember, otherwise all the things is very easy. Nu 2 minus nu 1. So match these things with the above things, that is, here you can see for d2 system the delta O will be nu 3 minus means the highest transitions minus the lowest transitions, and for d3 system it is the smallest transitions, means here if the question is about d3 system, so the answer will be which one? Tell me the answer. The lowest transition is here 14,900 centimeter inverse. Other one is, this is nu 1. Nu 1, nu 2, nu 3 is the lowest to highest transition. Just remember these things. Okay, so this one will be the answer because it is a nu 1. Okay, I can repeat the thing if you tell me. Otherwise, you can rewind the video. Just put a short note like this. I draw this thing and put right under these things. Okay, this have to you remember. It will be very easy and short trick to remember those things. Okay. So coming to the next question. So coming to the next question, here you can see the correct order. They want to know the correct order of the d orbital splitting in a trigonal bipyramidal geometry. This is, that is TBP. Okay, you have to tell the correct order of the trigonal bipyramidal. So the order is the, I'll direct want to write the order, but I will write the other orders as well. Means let me first write the order of the linear. Linear is this, like this, means okay. The order of linear is like this, means dz square will be the highest, dxz, dyz, dxy, dx square minus y square. Okay, for trigonal planar, अरे यार, trigonal planar, it is like this. Okay, so it is like this, the dx square minus y square, z component is not present here. So means axial positions are not there, that's why means x and y components will be dominant here. So xy, xz and dyz. Coming to TBP, that is, you know, all know, here z component is present, so z component is dominant. So it will be like this, dz square, dx square minus y square, dxy, dxz and dyz. Okay, so the, if we present in a energy order, it will be like this, means d orbitals are split like this. Here dxz, yz, dx square minus y square dxy and dz square. So same thing for pentagonal bipyramidal as well, but the energy order is reverse. Means it will be like here dz square, the xy components will come higher, xy component will come higher, xz and dyz. So coming to the next question, that is the species with the highest magnetic moment, that is spin only value, which one of the species will have the highest magnetic moment? So the magnetic moment is related to the number of the unpaired electron, because you know the spin only value is the root over of n into n plus 2. N is the unpaired electron of the following metal. So among the four metal, which metal have the highest means which metal have the highest unpaired electron, that will have the highest magnetic moment value? So starting with the VCl6 4 minus, it has V2 plus, vanadium 2 plus. So as we know that vanadium is the electronic configuration 4s2 3d3, but it is 2 plus, so 4s2 will be 0, so it will become 3d3. So it has 3 unpaired electrons. Next, coming to that eta 5 Cp2 chromium. Okay, so it has eta 5 Cp2 chromium. As we know that it has 4s1 3d5. Okay, so here it is chromium 2 plus, that is d4, and low spin. LS means low spin. Okay, this is like d4 system. So unpaired electron is 2. So one thing you have to remember here, that if the unpaired n value is 1, the value will be around 1.7 to 1.8. If the value is 2, the value is 2.8 to 2.9. The value is 3, if the value is 3, it will be near 3.9, and nearly means if 4, it is 4, it's 4.8 to 4.9. So the every value you can see, you can easily calculate without calculating with using a calculator. So here for 3 and equal to 3, the value will be 3.8 to 3.9, and for 2 it is 2.8 to 2.9. Coming to the next thing, there CO NO2 whole 6 3 minus. So NO2 is a strong field ligand that is creates CO 3 plus. So CO means S4S 2d7 3d7. So 3 plus means 3d6, and low spin means you know that d6 system, if have low spin, then it will all will be paired electron, so unpaired electron will be 0, so the magnetic moment will be 0. Coming to the next complex, that is NiEDTA irradiate 2 minus, that is Ni2 plus. Ni2 plus. Ni2 plus is has 3D8 system. So 3D8 system except square planar, it has high spin complex, means like this. It it has only one form, except in square planar complex it is paired up, but in octahedral complex it is like this only. So two unpaired electrons are there. So here magnetic moment is 0, here 2.83, 2.8 something. Okay, so they asked about the highest magnetic moment value for which complex it is. It is for the vanadium complex. So the answer will be this. Okay, coming to the next question.